Hey everyone, in today's video I'll be installing my new dust collection system. The dust collector was set outside in the shed to save space inside and reduce the noise. I used metal ducting and did my best to make it all look visually integrated in the space. Boom! Before starting the ducting installation, I wanted to replace the light fixtures for high CRI LED panels. I had my father helping me with the replacement as well as the rest of the ducting and dust collector installation. My idea was to install the dust collector in the shed and have the ducting coming into the studio through the glass door. So I ordered a glass that's a bit smaller than the existing one so that I could add a ducting port at the top. To make the port, I used high quality plywood and aluminum sheet to make a sandwich. I wanted to be sure it did come out strong and weather resistant. I used epoxy glue to bond the two materials together, leaving extra plywood in the side since it was the same thickness as the glass. I could then find the correct place to make a cutout for the ducting. I added another hole in the corner to insert an electrical wire and feed electricity to the shed. The spigot plate was glued with silicone and screwed to the plywood and aluminum sandwich with stainless steel screws. This one comes with rubber gaskets, which will be great to keep the pipe air sealed. I cleaned the excess silicone with acetone and spray painted it black. The old dust collector and dust separator could then be put aside as we proceeded with the new glass installation. The biggest complication had to do with the sealing rubbers that were always falling off. I don't know if this is normal or not, but eventually we were able to complete sealing the glass after some frustrating moments. To feed power to the dust collector, a new 25 amp circuit breaker was added to the electric panel and a cable was run over the drop ceiling. The cable used was pretty thick, so it can handle the dust collector electrical load perfectly. The dust collector I went with is a Supercell from Oneida. It's a revolutionary high-pressure dust collector that works well with up to 100 feet or 30 meters of 4-inch hose and ductwork. I did a lot of research before opting for this machine and got in contact with Oneida in the US to see if they would be interested in supporting my channel. They said yes, and they actually built a machine with electrical requirements to perform well here in Europe, which was absolutely amazing. If you live in the US, lucky you because you can purchase the Supercell right away. Oneida is contemplating the idea of making it available here in Europe too, so if you'd be interested in such a machine, please leave a comment below. I drilled a hole in the shed to run the power cable inside and the infrared dust level sensor from the shed into the studio. This sensor will be positioned in the dust bin and will make a red light blink when the bin is full. I had to separate the wiring from the lamp in order to fit the cable through the holes, and now I will reconnect it near its final position in the glass door. The electrical installation is complete at the shed for now, with a 16 amp plug for the Supercell, a regular European style plug, and I still have some extra space for a lamp, switch, or something else that I might need in the future. The Supercell I got is meant to be hung on the wall, although there is a mobile version available too. I took some measurements of the bucket and added some extra height for a wheel card that I will add later. At this point, I was following the included instructions and used the template to mark a bunch of holes in the concrete wall. The wall bracket was set in place, as well as the rear support brace that will prevent vibration of the cyclone and motor components. This part of the assembly went pretty quickly, although some changes were made to the step-by-step sequence. I didn't attach the bolt in the rear of the cyclone, and I also skipped forward into placing the motor over the filter before having the cyclone attached to the wall bracket. I had to do it this way, otherwise I wouldn't be able to fit the motor over the filter since my shed ceiling is a bit low. It is recommended to have a certain free space over the machine for easy replacement or cleaning of the filter. Unfortunately, I will have to get help and remove the cyclone assembly when the cleaning time comes. Hopefully it will only happen once or twice a year. Back at the shed, the machine was secured to the wall bracket with the provided hardware. Then I could finally insert the remaining bolt and attach the nuts and Allen spacer in place. This was impossible to film and quite hard to do actually. The dustbin will be connected to the cyclone through a small section of hose. I made a wheel cart to place the bin over and make it easier to move when cleaning. Okay, everything seems to be ready to test. I was really impressed with the suction power. Let's get started on the metal ductwork. The Supercell is a high-pressure dust collector, which means that the 4-inch hoses and ducting used with it need to be high-pressure vacuum rated. I went with 100mm or 4-inch galvanized spiral ducting in 0.7mm thickness or 24 gauge, which is the minimum of thickness recommended by Oneida. I had to order it from Poland because I couldn't find any factory in Portugal that could produce spiral ducting with such thick metal sheet in the latest months. Thinner sheet material can be collapsed with the high pressure from the supercell, so you will want to make sure to choose the right type of ducting. We went ahead trying it out, measuring, cutting, and attaching the components together. This was our first time doing this kind of installation and took us a while to finish the job, but overall I think it turned out great. I wanted the pipes to be hidden as much as possible, so I structured everything to be over the drop ceiling. Yes, this space is rented, and I will save the tiles from where the pipes are going down and install new ones with a hole for the ducting. The pipe and fittings were all connected with self-tapping metal sheet screws and high-quality aluminum tape to make sure that everything gets airtight. A nice thing about the Supercell is that you can use 90-degree bands, which is unknown to most dust collectors. The performance doesn't get too affected by the sharp angles, and this was one of the most important reasons why I chose this machine. To hang the pipe, we simply used perforated metal strap that I cut to a fixed length so that the suspension height was consistent. It was directly anchored to the concrete ceiling. Once the pipes were cut and fit tested, we could go ahead and make permanent connections. I got some dust collection accessories and fittings from Rockler, namely these blue mountable couplers, to secure the vertical pipes to the wall. Unfortunately, there is a horizontal concrete beam in the ceiling that complicated things a little bit and didn't allow me to make clean 90-degree angles going vertical along the wall. I checked all the joints and applied tape to any remaining spots until everything was nicely sealed. This was also a little hard to film, but I think you can get the idea of how it came about. I attached the blast gates, ports, and fittings to prepare for the flexible hose that will connect to each machine. I could finally find the best place for the dustbin sensor light. I was glad that I could keep the original cable length and still have the blinking light inside the studio. I decided to paint all the visible pipe matte black. I think it turned out better than I was expecting. I love how integrated the ducting feels in the space. The last bit of ducting that needs to be done is the connection between the dust collector and the glass door. I traced the perimeter of the port on the wall and roughly found the center of the circle. I took some measurements and drilled a test hole with a small drill bit from outside to see how good or bad my guessing was. It came out in the wrong place, but then it was easy to measure and mark the correct place to drill. I could then replicate the circle with a little wiggle room. Something I forgot to mention before is that most of the elbows that I got are adjustable, so I can rotate each section to achieve any desired angle between 0 and 90 degrees. I attached both ends with the adjustable elbows so that I could then measure the length of straight tube needed to complete the duct line. To protect the cables, mostly the small one from the dust sensor, I used electrical tubing that I cut lengthwise to being able to insert both cables. Then I covered the entire tubing with aluminum tape to make sure that no rain gets inside. The next day I painted this yellow because I thought it was fun, and I already had the small can of exterior paint for metal on hand. The Supercell comes with 25 feet or about 7.5 meters of reinforced 4-inch vacuum pressure rated flex hose. That's what I used to connect the blast gates to the machinery. And lastly, I used scraps of thick felt that were left over from my desk remodel to make the substitute ceiling tiles with the holes for the pipes. I wasn't able to find ceiling tiles similar to the original ones, but I think these turned out nicely. The system is now fully operational. It can be remotely turned on and off, and the airflow seems to be pretty good to feel with my hand. Let's now measure the suction on each port. I purchased a anemometer on purpose for this test, and I changed the area value on the device to match each port so that we get a truthful CFM number. Let's check the center port. This is where the airflow is better because it is mostly metal pipe and a very small section of hose. I'm getting 453 CFM here, which is very good considering that I have several 90-degree turns in the ducting. And here we can see that the air is traveling at almost 30 meters per second. So cool. On the CNC, I'm getting about 100 CFM at these 2¼ inch ports, which is great for the type of work that I do with the CNC. Just out of curiosity, let's measure the airflow on the dust extractor that I used to hook to the CNC. It used to work just fine for me, and as you can see, I can measure just 14 CFM out of this 25mm opening. If it already worked fine before, I believe that the new system will work even better. If I get the flex hose out of the way at the reduction port, I can read 171 CFM, so I can always change the hose to a smoother one if I feel that the ridges are killing the airflow. I got a long hose for the bandsaw and drum sanders, so I can move them around. Let's see the airflow that I'm getting. It seems that it maxes out at 342 CFM, and finally at the table saw cabinet I'm getting about 355 CFM. Now there is something left to talk about this setup: negative pressure. Since the air is being sucked out of the room, additional air needs to fill in the room. I had this in mind but didn't quite believe that it would be that noticeable in real life, so I basically have to keep a door slightly open to allow street air to enter the room and fill in the void. This could have been avoided if I had a returning hose blowing air from the dust collector back to the studio after being filtered. I might do something about it in the future. Until then, I will simply keep one glass door slightly open. So here it is, my new dust collection system that looks nice and performs great. Let's take a final look into the system. Here is the Supercell inside my shed. The ducting is running out and then into the studio through the small glass door. The ducting is turning up towards the ceiling to stay out of the way. I am really happy to see that it didn't come out too intrusive in the space, and the black paint made the pipe feel a lot warmer visually. I'd like to thank Oneida for taking the time and effort to build a machine to meet European electrical standards so we could make this collaboration happen. If you live in Europe and you would like to get a Supercell, write it down in the comments below and maybe we can give Oneida a little push to make it happen. A big shout out to all my Patreon supporters. If you want to support my work too, head over to patreon.com/gethandstory or visit my online shop. Thanks everyone for watching, and go get your hand story. Até já.